Our mission at Techion is to address a global problem, and it's a multi-sector problem. And that problem is that many tests across human health, environment, animal health rely on a microscope and a skilled technician to analyze what particular particles they're looking at. We build a digital microscopy platform, and by using digital imaging, cloud computing, and AI, we're able to automate some of those processes and bring a whole new rigor of QA and standardization across those sectors.
Traditionally, a farmer would have to take a feck test and send it in via a courier or a postage system, meaning the delay in their results could be up to a week. By that time, the feck levels will have changed. Our clients were more likely to rush into making the decision to treat their animals, and often unnecessarily.
So as our platform was growing and we were doing more tests from different countries and more animal species, we were striking a problem that we needed more online technicians to support it. So AI becomes an obvious solution.
So before Microvision, we needed to have technicians that were available 24/7. But in the real world, that just doesn't really work.
The Microvision solution that we developed with Techion is a completely bespoke neural architecture that we believe is the most accurate AI system for the speciation and localization of eggs from parasites in a veterinary context. Off-the-shelf computer vision just didn't work. We took state-of-the-art computer vision or object detection models, and applying it to this data set, the best performance we could get with a huge amount of tuning was about 47% accuracy. And we looked at different types of architectures, different models, and found one for crowd counting. So we adapted that architecture, we changed a huge amount about it, refined it for the use case that we have, and we're able to find the eggs at an incredibly high degree of accuracy. Training of our models was done in the Azure Machine Learning workspace, and we used the whole stack of Microsoft technologies.
We went with HSO because we're dealing with very complex biological samples, and we already knew enough about those challenges. And when we engaged with HSO, we engaged with people that understood our challenges very quickly, and we felt with confidence that we could move ahead with HSO where we weren't getting that from some of the other providers.
And over 3 years of iterative refinement and collaboration with Techion, we trained a model to over 95% accuracy, which is now comparable to clinical diagnosis for these conditions.
Since implementing Microvision from HSO, we have seen a fast, accurate, and reliable solution to our markup tech issue.
So we've now reached a point with the model's performance that we have been able to switch off our online technicians other than auditing, and we've now got the model deployed across multiple countries, multiple species, 24 hours a day.
A human technician can't spend 6 to 8 hours a day looking at eggs on a screen, but a computer vision model that has been trained to do just that will always outperform its human counterpart.
At its core, the Microvision solution that we built with Techion is incredibly general. And that means that we can apply this to the counting and speciation of cells in just about any context.
So what's next for Techion is that we take all the work we've done with HSO and Microsoft and the work we've done here, and we now radiate that beyond our current areas into areas like human healthcare and into water testing, for example.
We're really hoping that as we iterate on the solution and improve the quality of analysis, the breadth of things that we can test for, that we can better understand the world of microorganisms as they apply to us.
First of all, do your due diligence and find out and understand what challenge you're trying to address, and then quite simply, find the right partner to help you execute it.